Welcome to next lecture on network theory. In the lecture, we will discuss types of elements. So, circuit are different types of elements we use like voltage source, resistor, inductor, transistor, rectifier, okay. So, diode. So, different types of elements circuit la use pannrom. So, the over element is having different types of characteristics. So, on the different types of characteristics element they are classified into types of element அப்படினு சொல்றோம், right? So, based on that we have classified the types of elements. Enna types of element irukku appadina, first one active and passive element, linear and non-linear elements, unilateral and bilateral elements, lumped and distributed elements, last one time variant, time invariant elements. Next இப்போ ஒவ்வொன்றை பற்றியும் நம்ம டீட்டெயில்டாக என்ன அப்படிங்கிறத டிஸ்கஸ் பண்ணுவோம். ஓகே, ஸோ ஃபர்ஸ்ட் ஒன் டிஸ்கஸ் அபவுட் ஆக்டிவ் அண்ட் பேசிவ் எலமெண்ட் பற்றி பார்ப்போம். ஆக்டிவ் and passive that is first one. So element that can generate the signal or amplify the signal or rectify the signal. இந்த மாதிரியான டிவைஸ் என்ன சொல்றோம் அப்படின்னா it is called as an active element. ஒன்று சிக்னல் அதுவாக ஜென்ரேட் பண்ணணும், இல்லை அப்படின்னா இருக்கக்கூடிய சிக்னலை ஆம்பிளிஃபை பண்ணணும், இல்லை இருக்கக்கூடிய சிக்னலை ரெக்டிஃபை பண்ணணும். இந்த மூணில் எந்த ஒரு ஒர்க்கை பண்ணாலும் அந்த எலமெண்ட் இஸ் கால்ட் as an active element. அதர்வைஸ் மற்ற எலமெண்ட்ஸ் எல்லாமே we can call it as a passive element அப்படின்னு சொல்கிறோம். So definition for a active element: the element that can generate a signal or amplify the signal or rectify the signals is called active element. Elements otherwise it is passive. It's an passive elements. So the element that can generate a signal or amplify or rectify the signal is called an active element. Otherwise it is called as an passive element. So example for active and passive elements என்னென்ன அப்படின்னா active element ஓட example for active elements. So என்னென்ன examples பார்க்குறோம் அப்படின்னா first current source and voltage source. current source and one is voltage source, current source, voltage source. Next transistor. Next it can amplify and rectify. So amplification means amplifier, op amp. So rectify பண்ணும். So diode and SCR is also a active element. Next triac and diac. So these are all some of the active element example for active elements. Next passive elements, இதெல்லாம் passive elementல வரும். So passive elements, என்னன்னா resistors, inductor and capacitor as well as transformer, these are all comes under passive elements. So resistor, inductor, next capacitor, and the other one is transformer. This transformer. So these are passive elements. Example for passive elements. Right. So one more note point. So we are representing active and passive element in 4 quadrant. We represent the passive element always having the positive slope, and the active element is always having the negative slope. Okay, note point for passive and active element. For example, I am taking current and voltage I, V, same I, this is I, V and V, right? So first one is passive element. So passive element always having the positive slope, This is a passive element. So this is a passive element, positive slope. So slope in a positive slope. This is passive element. Element is a passive element. Passive element. So in the representation it is called as a passive. Then what is active element? So active element always having negative slope. So negative slope, that is called active element. It's called active element. So that's all about active and passive element. I have to mention here why it is active and passive. This is voltage plus, current plus, here voltage, current minus, voltage minus, here plus, minus, plus and minus. 4 quadrant for it's 1, 2, 3, 4, right? So that's all about active and passive elements. Non-linear elements. So mostly in the linear, non-linear elements அப்படிங்கிற இந்த வெரிஸ் அதிகமாக நம்ம கேள்விப்பட்டிருப்போம். linear element அப்படின்னு மோஸ்ட் ஆஃப் த வைவா கொஸ்டின்ஸ்லேயே இந்த லீனியர் அப்படிங்கிறதுக்கான மீனிங் என்னென்ன இன்டர்வியூ நிறையா கொஸ்டின்ஸ் வரும். ஸோ லீனியருக்கான டெஃபினேஷன் என்ன அப்படின்னா அவுட்புட் ஃபாலோஸ் த இன்புட், தட் இஸ் ஒன் டெஃபினேஷன். அவுட்புட் ஃபாலோஸ் த இன்புட், இது ஜென்ரலாக எல்லாமே சொல்லக்கூடிய பதில். So next, another definition for linear element அப்படின்னா the element that obeys superposition and homogeneity principle is called linear element, otherwise it is called non-linear element அப்படின்னு சொல்லுவோம். The element that obeys superposition and homogeneity principle is called linear element, otherwise it is called as a non-linear element அப்படின்னு சொல்லுவோம். So superposition theorem and homogeneity principle you are well known. So superposition theorem அப்படின்னா if ஒரு சர்க்யூட்ல 2 or more sources is acting அப்படிங்கப்போ we are making any one source deactivate பண்ணிட்டு so individual source ஓட contribution என்ன அப்படிங்கிறத find out பண்ணுவோம். That is superposition theorem. So homogeneity principle, if both the values are opposite in an equation, so opposite values are, both the values are same அப்படிங்கிறத நம்ம அண்டர்ஸ்டாண்ட் பண்ணுவோம். அதை தான் இந்த ஹோமோஜெனிட்டி அண்ட் சூப்பர்பொசிஷன் பிரின்சிபல் வந்து சொல்லுவோம். ஸோ யுவர் எலமெண்ட் should obeys the superposition theorem and homogeneity principle is called linear element. Is not obeying these two conditions, so it is called as a non-linear element அப்படின்னு சொல்லுவோம். Another definition for linear element, you know, the characteristics line of element should be straight line and passing through the origin of the graph. That is called linear element. So characteristics of the element எப்படி இருக்கணும், linear straight line இருக்கணும், and it is passes through the origin இருந்தா that is called as a linear element, unless otherwise it is called as a non-linear element. Definition. So or another definition for a another definition for linear element, the characteristics are straight line and passes through the origin is known as a linear, otherwise is called as a non-linear element. So example, here you can see the first, we can draw the characteristics curve of the resistor. So resistor we are taking number previous we are taking ideal resistor, right? So resistor I, current is I, voltage V, this characteristics is V R. So this is R, this is R. Characteristics of the resistance is a straight line. So I am taking, I am என்ன எடுத்துக்கணும், resistance is a linear element எடுத்துக்கணும். So R and this characteristics curve 0. So R that is equal to V equal to I into R. So R equal to this, R equal to V by I. This is the linear. Next we are taking for inductor, that is psi, and current I, that is also, so we know L equal to inductor L equal to psi by I. I am நாம் இங்கே linear inductor linear element எடுத்துருக்கோம். So the line is straight line and crossing the 0 or starting from 0 or crossing the 0. Also see for a, this for an inductor, this for an inductor, and you can draw it for a capacitor. Capacitor, so voltage we are drawing it for voltage, charge and voltage, that is C, capacitance. Capacitance equal to charge divided by voltage, charge divided by voltage. So the characteristics are linear. So these characteristics are linear characteristics. So resistor, inductor, capacitors are linear element. So linear element example, resistance, inductance, capacitors are linear element because for characteristics curve number we are taking as ideal resistance, ideal capacitor and ideal inductor. So energy losses illa அப்படிங்கிறது practical inductorல we are taking inductor, capacitor and resistor, right? So inductor, resistor, capacitors எல்லாமே having a or linear element. Okay. Next we are taking example for non-linear elements. So non-linear, for example that I am drawing it for diode. We can draw the characteristics for diode. Characteristics for diode. So what is the characteristic? This is the characteristics, current, voltage, sorry, current and voltage, same way voltage and current. So this is the characteristics of diode. So ಇದು original cross ஆகும். So diode ஓட characteristics, the characteristics crossing in a origin, but it is not a straight line. So diode is not a linear device. So origin la cross ஆனா மட்டும் பத்தாது, it should be a straight line. So example, you also take SCR or triad. This is also non-linear element. This is also a non-linear element. So this is the difference. So the graph are different. So linear அப்படிங்கிறது it is crossing the origin and it should be a straight line. But non-linear, it is also crossing the origin. Origin cross பண்ணுது, but it is not in a straight line. Okay. So this is about representation of linear and non-linear element. So examples for linear elements are resistor, inductor and capacitor. So non-linear elements Non-linear elements are SCR, triac, diac, diode. So these are all the example for non-linear elements, right? So you can write the example for linear. Uh, write the example for linear elements. You can write here. So linear, so example for linear elements, that is example for linear elements is resistor, inductor, capacitor are a linear element. So non-linear element, that is diode, SCR, triac and diac. So these are the some of the non-linear elements: SCR, triac, diac, transistor. Okay, so transistor, op amp. So these are all the example for non-linear elements. So இப்போ difference தெரியும். So அங்கே active and passive device. So active device எல்லாமே is a non-linear device. So passive device எல்லாமே is a linear device. அப்படிங்கிறது based on these two comparison you can understand, right? So next, so that's all about linear and non-linear elements. Linear and non-linear பார்த்தாச்சு. Also, இன்னொரு condition note by initially charged inductor and capacitor. Charged inductor and capacitor. So you know, inductor and capacitor are linear. Inductor and capacitor linear we know, right? But note point la, so என்னன்னா initially charged inductor and capacitor are non-linear. Initially charged inductor and capacitor are non-linear. Initially charged, we know the equation for inductor and capacitor. Just we take it for voltage V or capacitor V C of t, that is equal to, we know, V 0 of t plus 1 by C integral 0 to t I of t into dt. Initially charged capacitor inductor, I don't know what is initially. So graph draw. For example, drawing the graph. Right. For example, inductor அப்படினா it is a side and so voltage and current, right? Voltage and current. Voltage and current. So initially charged, I don't know. So for at time maybe இதுல வந்து 10 volt இருக்கலாம் plus something. This is a value is 1 by C integral 0 to t I of t into dt. So above, for example, 10 அப்படினா this is a 10 volt. This is a 10 volt. So above the graph will start from here and it will moving like this. So graph is start from here. So graph எங்கிருந்து start ஆகும்? So இங்கிருந்து start ஆகும் and then it will move. So அப்போ என்ன ஆகாது? It will not cross the zero origin start. So initially charged inductor and capacitors are non-linear. இதுக்கு முன்னாடி ப்ரீவியஸாக கெப்பாசிட்டரில் என்ன எனர்ஜி இருந்ததுன்னு தெரியாது, என்ன எனர்ஜி ஸ்டோர் ஆயிருந்துச்சுன்னு தெரியாது, as well as இண்டக்டர்லையும் என்ன எனர்ஜி ஸ்டோர் ஆயிருந்ததுன்னு தெரியாது. Okay, so initially charged inductor and capacitors are non-linear. At generally